Hi everyone, my name is Bo Huang. I'm here to present to you about a digital earth product that we're working on. Our website is SenseEarth, senseearth.com. What we do is we are producing a digital earth based on real life data. For example, from the picture you see that this is a first person view of London neighborhood. Okay, so these are real buildings based on GIS data. You could see that there are a few, say, telephone boxes. This is like a symbol of a bank, bus stops. And these are additional views. Wow, the internet is really slow. But you get the point. See, we have first-person view and the third-person view. Different pictures of how London looks like in a more, say, stylized setting. Pictures of Stonehenge. And then I could just leave it for you to check out the website. But this is mostly a demoing session. What I will be doing is that, today's the demoing session. Tomorrow I will also have a session in which I will be speaking about what this product is used for and its potential use cases. So I think what we do for this time is that I will just open the program for demoing. And you could take a look at it for a few minutes. Then afterwards, you're welcome to come up, and we'll plug in the Oculus, and you could just see it in first person and with you. Please.
WebGL, OpenGL?
This actually uses Adobe Air, but we will be using a lot of WebGL in the future. So this is mostly, because my background is games. I've been doing games and 3D graphics over 10 years. I mean, my first company was Namco. I was working on Pac-Man, Miss Pac-Man, Time Crisis, and other IPs. And subsequently, I became an engineering scientist at Xrite Incorporated, where we were working on real-life simulations of materials. What that means is we work with color scanners, and the color scanner would scan, say, plastic and plasters and carpets. So I use the various things I have learned in the past decade on data. And what we see here right now is a view of San Francisco, the Bay Area. So as long as you go up, you can see more of the view. And it's loading data dynamically from the web. And we are using actually a lot of open source data. For example, here in this map view, we are using a lot of OpenStreet mapping data. And that's one of the reasons I come to this conference to give a talk, because we imagine that in the future, all of your devices will be giving a lot of location-based data. Your mobile phones, your security cameras, your smart devices at your home, smart sensors, robots. Everything will be generating data because everything has, sensors of different kinds. Your mobile phone has a gyroscope, accelerometer, magnetometer, just to point out a few. So they will be generating data, and we need a place to put them. And what we imagine at SenseEarth is that, maps is a place that you want to be. And with this map, we could go anywhere in the world. So I could just type in address. For example, let's just, it's to Paris. Okay. So I searched for Paris and it came up with a list of results. I'll just click on the first one. And now it's loading the data in Paris. And as I was showing earlier, that it's loading the data, and sometimes it's slow, sometimes it's fast, depending on your internet connection. But to go back to what I was saying earlier, a lot of this is about you need place to store the data, and you need and those devices that we will all be working on in the Internet of Things revolution, they will be also be consuming data. So, for example, your smartphones or some kind of weather sensor, they may want to know what's around them. Like if you know what's around them, then you can mine more data from nearby locations. Imagine, say, on this bridge and on this river, we will be, say, placing cameras on. It's better I stop. Okay, I'll just let it stop and let the 3D buildings slowly turn out. So imagine that, say, if you pretend that there's buildings around you, increasingly, we will be installing smart sensors. For example, security cameras. That's the most relevant, and on each side.
Excuse me. We can bring this down for you.
Oh yeah, it's kind of covering me, huh?
Yeah. Will you be able to see?
Yeah, I should be able to do fine. Yeah, it's a little bit awkward, but I should be able to do fine. Okay. So I think this is basically what the product is about. This project's under active development. It's a Apache.org feature project. So you could find our product on Apache.org as a showcase product. And because it's a Oculus feature device, and it is also downloadable on Oculus Share. So you could go to Oculus or go to our website to take a look and see it, download it for yourself. I could demo a little bit of an option that you could do, because right now the Oculus uses for those I'm pretty sure most of you probably know, but Oculus is like a virtual reality device. It looks something like this, and it's like a goggle. This is where I put on my geek glasses. Literally. Okay, and this device costs about $200 and $300, so it's really not that expensive. And because Facebook bought them, they will actually go down in price later on. And not to mention that there are also additional alternatives, such as the Google Cardboard, which is just costs a few bucks. I mean, just $20. Okay. Usually you would turn on the two eye view so that you will be tracking the so you will be adaptable to this glass. And you could turn on whether if you want distortion or not. This makes the program run faster because it uses a lot less shader and computing power, because this is like the warping view. And there are also some other bells and whistles. Such as you could turn on the sky. That's just a little bit of a graphical eye candy. But mostly that you could just go all the way up and do your own navigation. Well, I better turn this up. I mean, Sky gets a little bit buggy because we are building a beta software. Okay. So as you go all the way up, that you can see more. Okay, I think I blattered on long enough. It's like, do we have questions on this type of things? And of course, if there's no more questions, I could leave this open so that anybody who wants to give it a try, then you just please come up. Please go ahead.
You said you're drawing this in Flash. Is there an SDK already in Flash to do the working with it?
Well, we use a game engine for it. So one of the game engine components is Away 3D. Actually, I should say that we're not exclusively Flash. we use a language called Hex. And Hex is very similar to Flash, so that that's why I say it would be easily adaptable to WebGL, because Hex is a language that compiles to multiple targets.
So there's a Hex library that does it.
What was that?
You said there's a Hex library that does it?
Well, this is our own product, so that we have our own IP that's developed from scratch. So we're now using, say, Google Maps. We're not using any of their API. This is based on, say, the fruit of our R&D effort in the past year. So because, what we do is that we use the raw geometry data, and that's served by OpenStreetMap, being our primary source. And we use the boundary data and generate the 3D buildings, and also generate the collision geometry, so that when you walk around the building, that you don't walk through. Because if you compare to similar products like Google Earth, you just walk through the building like you're a ghost or something.
And your topo data?
What was that?
Your topographical data, elevation data?
The topographical data would be the next step. We are actually talking with, say the Monterey Bay Aquarium. They actually have a lot of what is it? They have a lot of undersea data, because they have their new submarine. That goes undersea and collect the elevation data. But I mean, that's something that interesting that I just thought I would share, because you would otherwise also be able to get, say, data from NASA and from our geological surveys. But for the time being, that we're mostly focused on just map data by itself. Until that we find that, well, okay, maybe in the future you'll be installing a lot of sensors in mountains and other places that's relatively remote. But for the time being, that we are more interested in like a urban solution, urban environment like this. Oh yeah, and I mentioned that, okay, you could see some shadows, and when I go up and down, you don't go through the buildings. And everything is real. Yeah, I'm really curious if you guys have any suggestions or feedback as well, because this is like a relatively short session. Yeah, 11:20. Okay, we still have 10 minutes or so.
So the reason I was asking about topographical data is I know there's a person here in San Francisco who's taken the topographical data for the world from a flight simulator and used paints and used the basically grayscale paints and compressed 65 gigs of data down to 3 using the paint for height maps. Is that a technique you're using? Well, you're not using it yet, so
Right, it really depends on the use cases that you're looking for. I mean, what are you looking to use the height map for example?
Well, for example, in San Francisco here, if you didn't really know the elevations, I mean, it wouldn't be all that realistic with flat streets.
That's true.
Everywhere, so.
Yeah, and for this particular application, that we're also interested in, what is the target audience, right? Like, say, we are building a platform for the future. Because right now, the Internet of Things revolution is coming and is happening as we speak. But at the same time, what are some, other than your cell phones, what are some sensors that you already have at your home? They're not really there yet. So we're building the platforms that, right now we're doing outdoors, but eventually that we're going to be making some kind of indoor environment as well, so that you could more accurately represent your data and represent your devices in virtual reality. And one of our goals is to democratize the decision-making process via the visualization. For example, if you think about, say, because most of us deal with data here, right? So I mean, data is very ubiquitous, but it's also very abstract. I mean, they are stored in our hard disks and our flash memories, but oftentimes you just don't know what they are. You have to open some program to see them, whether it's Excel or your machine learning programs. And those probably have like a very high barrier of entry. That you need to be an Excel jockey, and of course, just like the previous speaker, that you need to be really versed in machine learning, or at least statistics. And how current workflow, say for example for decision making, is that, for example, imagine that you're a CEO of a large company and you have a lot of data, and most likely you probably don't have any statistics background, and you will be depending on your data scientists to guide you through, okay, what do the data mean? So one application we imagine is that, if we could just plan the data in the map by itself. For example, one project that we have been working on or considering to do is to visualize the import and export data of California and to other parts of the world. Like by seeing, where is our products going and where are we buying our products from, other than our major trading partners such as China and Europe, what kind of conclusion can we make? And can a girl in elementary school or in middle school understand it just as well as a CEO without proper data training? And by doing that, we want to legitimize, government's decision-making process. Yeah, I'm really curious of the application that you were thinking about. In case I blabbered on too much. Okay, I think we still have a few minutes. If I could plug it in, and in case anybody wants to give it a try. And for now, I have to unplug this because it's using the same HDMI cable. Yeah, I'm really excited to be here today. And as I said, tomorrow I will have a session that I will have actual slides and talk about potential applications and the justification of why are we making like a meta Earth based on real data.